Hi everyone, my name is Lydia and this is what I wish they taught me about econometrics and introduction. In the previous two videos, we saw step-by-step procedures for both the critical value approach and the p-value approach to doing hypothesis testing for one single coefficient. In this video, we're going to talk just a little bit more about the differences between the critical value approach and the p-value approach, and why do they have different decision rules. So the decision rules that we had was that if in absolute terms the t statistic that we computed was bigger than the t critical, then we reject the null hypothesis, while for the p-value approach, it was that if the p that we have computed or associated to our t statistic is smaller than the p critical, then that's when we reject the null hypothesis. The reason for that is because of the inverse relationship that exists between the p-value and the t statistic. So if this is your t distribution, 0, we go, let's say, in here, 1 and -1 here, -2, -3, then 2, 3, okay? Remember, as the t increases in this direction, the p-value, which was something more extreme, way beyond what we observe, which would have meant that the p-value is basically the tail of whatever is left on the right-hand side. So for that purpose, let's look at a t which is 1, and let's say a t that is exactly 3. For a t equal to 1, then your p-value, so everything more extreme, is this entire area right here. So this is a p-value for that. However, for something that is beyond 3, the p-value would be instead this area that it's in orange. So look, as we are increasing our t value, then we are decreasing our p-value, which would make sense then that the signs in here are inverted for the two decision-making rules, okay? Since we are on the topic of using the graph here to very clearly see where it's basically our p-value and the like, let's also use this video to define what is your rejection area, because ultimately graphs are such a nice way for you to always be sure that you are making the correct decision, whether you're using the t-value approach or the p-value approach. So for one-tailed tests, okay, you're going to be looking, let's say, if your alternative hypothesis was that the beta is bigger than 0, and let's make this the alternative that your beta was smaller than 0. For the cases where the beta is bigger than 0 on a one-tail test, then let's say that our t star is computed as 2.5. So what we have to do is simply make sure, okay, this is where our t star is, 2.5. Okay, or let's make it actually a little bit more concrete. So if this is 1, this is 2, and this is 3, let's say 2.5 is here. So this is where our t star is. Remember, for the procedure, we always said that we also need a significance level. So for both cases, let's say that it's 10%, okay? And then I would need to find the t for one tail 10%. Once you find that, you'll know straight away that it's somewhere here. It means that your rejection area is defined by your t critical. So it means that anything that is on this side will be rejected. So whatever number you have, and it doesn't have to be the 2.5, it can be the 2, it can be the 3. As long as it is in this rejection area, then you can very clearly state, yeah, we reject the null hypothesis. Which means that when you do exactly the same thing For the alternative where the beta is smaller than 0, now you will understand that we will look at the opposite tail. So let's say that this is our T critical. It means my rejection area will be in here. So any T star that you compute that it's anywhere in here, you can say reject the null hypothesis. And if you compute a T that it's anywhere in this area, it means that you fail to reject the null hypothesis. For the two-tailed test, that 10%, so if this entire area here was 10% and then this entire area here was 10%, for the two-tailed, where you have that the alternative is simply beta different from 0, it means that if your significance level is still the 10%, you are splitting the 10 in the two tails. So it means that you have this area here of 5% and this area here of 5%, which means that you have here T critical for 5% and then minus T critical for the 5%, okay, on the one-tailed. Or you can write it here as T 10% two-tailed, but it's a little bit easier to write it as T critical at the 5%. Okay, so it means that now you have two rejection areas in the two-tailed test. Okay, so you have this area right here and this area right here. So whichever side you're at that is within this highlighted part, you are rejecting the null hypothesis. If you are anywhere in here on your T star, then you are failing to reject the null hypothesis. Okay. For the p-value, it's exactly the same. The areas will remain exactly the same, but now you just look at the areas instead of also including the t's in there. I hope this was helpful. It's going to become even more helpful in the next few videos where we're going to work a few exercises. So stay tuned and I'll see you in the next video.